And so this is going to be a talk on kind of some conceptual work that I've been doing and how it connects to some empirical work that I've done in trying to kind of like figure out what are we even trying to do in this field of kind of AI alignment that I've started working in, especially from the perspective of someone who kind of came from the more kind of traditional NLP world. So to start us off, some of us might be familiar with this kind of like, I want to say ongoing, but it's kind of fizzled out a little bit, this debate over the idea of language understanding. Like, do language models understand language? And in this debate, you have people on one side basically saying like, look, they can do lots of tasks that involve language. They have behavioral evidence of language understanding, therefore they understand language. And on the other side, you have people like, well, they fail in all these like really weird and unhuman-like ways, and they don't generalize, and that means they don't understand language. And if you've been unfortunate enough to like really dig into this debate, you probably found it a little confusing and kind of based on terminology. And like a lot of the distinctions that people are trying to make are more or less semantic about like, well, it depends what you mean by understanding. And I actually think, as a linguist, I think semantic debates actually can be quite interesting, because like the concepts that we choose they guide our inquiry. And like even though there's no like objectively correct concept for a word, there can be more or less useful notions that you adopt for a word or for a term like language understanding. And so I'm actually going to present an argument for what I believe to be like a useful notion of language understanding that can guide our inquiry. And it's closely related to this other problem that I've been thinking about a lot, which is the alignment problem. Broadly speaking, this is if we have a powerful AI system, we want to get it to do what we want. And yes, that's like very vague. Part of the alignment problem is making this problem less vague. One way of making it a little bit more specified is often called the agent alignment problem, where you have a powerful AI system and you want to get it to do what a single person wants, so that you don't have to run into these questions of like whose values or like how to aggregate preferences and that sort of thing. And that itself is still a very hard problem. But as AI systems get more powerful, get more ubiquitous, we don't want to lose control of society. We don't want to lose touch with reality. There are like certain forms of kind of like, there are certain forms of failure here that like to our lights might be unambiguous that we want to avoid. And like, it's worth trying to make progress on this problem. And I think that like one way of characterizing what it means to make progress is that we broadly want to align AI towards the true and the good, whatever those things are, right? We want to stay in touch with reality, and we want AI systems to do what we think is right, at least when we delegate tasks to them. And so my main contention that I'm going to be sharing today is that basically I think that language understanding and AI alignment are essentially the same problem when language understanding is conceived in the most useful way. And so now I'm going to discuss what I mean by language understanding. So suppose you have two agents, A and B, and A has like a meaning that they want to communicate to B. So here we have a burger. Maybe you're thinking of a burger. You want to communicate the idea of a burger. So you say the word burger, right? And communication succeeds. And we would say that language understanding was achieved if B is like, yes, burger, right? The meaning is conveyed. And when people talk about like, language models don't understand language, often what they say is, well, they don't have intent. They don't have like a meaning that they're trying to convey. They're just like producing symbols, and that like language meaning and language understanding is about the relationship between, meanings and symbols. So under that view, in order for language understanding to happen, you have to be able to succeed at this game. At this game, which is often called a Lewis signaling game. It's kind of one of the simplest game theoretic kind of formulations of communication, where you basically just have two agents and you have a set of meanings and a set of utterances, and these are distinct sets, and the relationship between them is arbitrary. But you want to be able to communicate a meaning using an utterance. And the solution to this game, if you have kind of two strategic cooperative agents and you're doing game theory, is for there to be a convention of mappings between symbols and meanings that you can use to determine your utterances. And from the view of a strategic agent, basically A wants to produce the utterance that A expects B to map to the correct meaning, but B wants to map the utterance to the meaning that they think A intends. So there's like mutual mental modeling that's kind of mutually recursive, and until it grounds out in what we call common ground about convention, which means that we all kind of presuppose that we all presuppose that we all presuppose, et cetera, this mapping between symbols and meanings. And so this is the kind of like condition, this is a criterion for success in language understanding. You need common ground between agents. So I think this is the kind of useful notion of language understanding between humans who are strategic, cooperative agents trying to like achieve this goal of communication. But what happens when we bring machines into the mix? It changes the game a little bit. And so I'll illustrate that using a thought experiment, which I call the dinner non-dilemma. It would be the dinner dilemma, but it's actually not a dilemma because it's quite easy. The circumstance is it's about 5 p.m. You're at the end of your workday and your phone dings and you see a notification with the name of your friend Jennifer and the word dinner with a question mark. What do you conclude? What conclusions can you draw from this situation? You probably will conclude that your friend Jennifer is thinking about having dinner with you tonight and wants to know whether you're available and interested. And you're correct. So communication succeeded. But how did you do that, right? How did you conclude something about Jennifer, who's like, you know, probably many yards away, opposite side of the office or something, just by seeing this, like, these symbols on your phone? And this is basically your ability to solve a different kind of communication problem, which is a slight generalization of the signal game that I was just discussing. So I'll call it a human-machine signaling game. And basically what happens is Jennifer, or A in this case, has an idea that she wants to communicate to B. She decides to type, you know, dinner question mark on her phone, press send, and this produces a notification on B's phone, which then B notices, sees the words, and concludes, Jennifer wants to get dinner, right? So there's a little bit more going on here than in the previous game. And what I would say is there are two additional games of communication that the parties are succeeding at here. One is what I would call the information game, where B sees their phone, sees, you know, sound effects, sees images, these are basically symbols, and concludes that something happened on the other side to produce that, right? Concludes that A must have done something to produce this notification. And so B can conclude this on the basis of their understanding of the relationship between their machine, their phone, and the real world. There's essentially a model of the generative process for the notifications that you see on your phone. And on the other side, A decided to type this word and press send on the basis of a mental model of what related this machine to the world, that if I type these words and I press this button, this is what's going to happen on the other side. And so essentially success at human-machine signaling games depends on the human's model of how the machine relates to the world. It's a lot like human-human signaling games, but instead of being mutually mentally recursive, it just depends on your ability to model the machine. So we can generalize this a little bit because I kind of outlined two games. Really, these are instances of like a more general game, which I would call a human-machine coordination game. So you have a human and a machine, say a language model, and here are the kind of conditions that you're in. Both the human and the machine get some inputs from the world, which may be distinct. Maybe the machine has access to some information that the human doesn't, and vice versa. They exchange signals, maybe through like a sequence of exchanges. So not just one message, but you can go back and forth, and then they each take actions. And the goal of this game is to maximize the utility of the human with both actions. And now it might be clear what the connection is to AI alignment. I think that this is essentially, like, success at this game is essentially the agent alignment problem, right? You're trying to communicate with the machine to coordinate on a shared goal. But what I hope is useful here is that I've characterized it in terms of language understanding and in terms of like criteria for success that we can actually think about making progress on, which is that how does a human know how to behave in this game in order to succeed? It depends, again, on their model of how the machine relates to the world. So progress on AI alignment means building machines with legible models of their relationship to the world. So they should be modelable. We should build models of them, and we should interact with them in ways that help us understand how they relate to the world. Right. So I'll just run through some quick examples with actual language models, which I think the text is probably too small here to actually go through, but I'll kind of give a high level sense of what this looks like if we're thinking about chatting with actual language systems. So I had a few language systems, and I asked them all pretty much the same question, which is, what does the American Heart Association say about polyunsaturated fatty acids? And if I ask this to Claude 3, it lists a whole bunch of points. It says a bunch of things about PUFAs, some of which it claims are said by the American Heart Association. And if you read this, right, you exchange these signals. How confident are you that it is representing the American Heart Association's view? And what gives you that confidence? Why are you confident? I'm not going to answer this question. This is kind of a mental exercise. I don't think the answer is very hard, but it gets us to think about the right kind of thing, especially when we compare to another system. So say Perplexity. If you have never used a Perplexity search engine, the way it works is it basically finds pages on the internet, consolidates them, and gets a language model to summarize them. So if we ask it the same question, it directly cites a couple of American Heart Association sources, and then it summarizes them in a paragraph. So I would ask again, how confident are you that it's representing the American Heart Association accurately, completely? And what are the factors that lead you to be more or less confident here? And finally, with Google, if I ask Google this question, it actually it provides a highlighted snippet of an American Heart Association webpage. So what is our confidence here? That it's representing the AHA accurately and completely. So I looked into it a little bit more after looking at all of these. And it turns out that Claude 3 provided probably the most complete and correct information about PUFAs, but a lot of it was actually not consistent with what the AHA says. Google was, of course, perfectly accurate at reporting some of what the AHA said because it provided a snippet directly from their website, but it wasn't totally complete. Whereas Perplexity was kind of between the two, where it summarized the two relevant web pages I could find from the American Heart Association. But the point that I'm trying to make here is that it's not just a matter of whether it's correct or not. It's a matter of like, what's our model of how the system works, and how does that allow us to be more or less confident in the output or infer something about the world from the output? Because making progress on coordinating with these machines looks a lot like figuring out how to draw inferences about the world from what they do. So you can talk about the capabilities of the AI system in terms of like its ability to answer questions correctly, but that may be a slightly different question from like, given its level of accuracy, what else does it allow you to infer about the world? How calibrated can you be about it? How confident can you be in it? And this is kind of like the crucial kind of marginal question for alignment over just advancing AI capabilities, so to speak. So on that note, I will propose a way to measure progress on AI alignment based in this framework. So I'll make some key assumptions in order to just like facilitate quantification and measurement. First, we're going to look particularly at the kind of information aspect of the game, where we want to test human AI coordination in answering questions. And we must know answers to the questions statically. Because we want a replicable and comparable measure between kind of like AI alignment approaches. And so for that reason, we're focusing on question answering benchmarks. But I promise that like, I want to relax these assumptions in future work. This is just to kind of give a first pass at like, how would we even go about trying to quantify progress in AI alignment as such, beyond kind of traditional notions of progress on benchmarks. So the experimental paradigm is like a slightly simplified version of the human AI coordination games I was talking about, where you have a human and then they interact with a model in some way through some interface or tools around that model and an interaction protocol. And all of these aspects, the model, the tools, and the interaction protocol, are parts of the system that you're testing for kind of like level of success at alignment. But what we do is we give the question to the human, we let them interact with the system, then we have them answer the question. And what we want to do is measure accuracy. So here we're basically, instead of just like saying we want to maximize the human's utility, whatever that is, we're using this kind of like statically measurable notion of utility, which is like accuracy at answering a question with the help of an AI. So we're saying, okay, the human's goal, we're asking them to answer the question correctly. But one of the really important things we have to do is compare to a couple of baselines. One is a kind of deferral to the AI baseline, where if you just present the question directly to the AI and regurgitate its answer, then what accuracy does that get? Because you don't really have to understand anything about the relationship between the AI and the world to do that, unless you think, oh, well, it's probably accurate, or it's probably more accurate than I will be. So you want to be able to do better than this through coordination. And of course, you also want to do better than the human on their own, because we want them to actually infer something new and useful about the world on the basis of this interaction. So the way that you measure success is you take your human baseline and you take your AI baseline, and then you look at kind of the human AI team, and you look at the delta between the max of the baselines and that collaborative score. So this delta, I think, essentially quantifies how much useful information the human can infer about the world from interacting with the AI. And something else really useful about this operationalization is that this delta should capture something about the human's ability to supervise the AI system to improve its alignment. Because if you can coordinate with the AI to perform better at your goals, you can feed that back in as a supervision signal to push the AI towards that level of performance on its own. Now, this is actually very closely related. It's pretty much the same as an experimental paradigm that was proposed in the alignment literature called sandwiching. So sandwiching is a proposed evaluation method for a scalable oversight, which is the task of supervising AI systems to do tasks that we can't do on our own, or that we have a hard time verifying or evaluating performance on our own, which, as you can imagine, is very close to the kind of evaluation setting that I care about, where you can get gains from collaborating with an AI. It's called sandwiching because the idea is that you want to have some kind of ground truth, statically measurable outcome to serve as kind of your target that you want to achieve. But you want a non-expert human who can't kind of achieve that on their own to be able to supervise an AI to get expert level performance, or to approach that ground truth. And the idea behind this as an evaluation paradigm for supervision methods is that if a kind of like non-expert who can't do the task on their own can still align an AI system to do the task at an expert level, then maybe experts could like align the system to do the task at like a superhuman level, so to speak. And if you can figure out a way to do that, then you can take the human's decision or the decision-making process or the interaction protocol and actually feed it back into the AI. So things like reinforcement learning from human feedback look a little bit like this, where like you get human judgments on a bunch of data, then you build a model of the human judgments, and then you can do self-play against that with reinforcement learning to improve the performance of the machine. And so the sandwiching scalable oversight paradigm is kind of a way to identify promising methods for doing self-play with RL in that way. So my claim here in this talk that's kind of unique apart from sandwiching is that like success in sandwiching concretely relies on the non-expert having a good model of how the AI's behavior connects to the world. That's how we can actually expect to get better performance than just deferring to the AI system as it is. And also that this is kind of functionally what language understanding means with machines and why these problems are so closely related.
Can I ask a quick question?
Oh, of course. Yeah.
There's a few things that have come up throughout your example, and I just want to make sure I'm understanding some of this. So how the AI's behavior connects to the world in the case of the PUFAs is basically source attribution.
Right.
Yeah.
Yeah, sorry. And also feel free to ask questions and interrupt, especially, in fact, this might be a good time if there are any other questions before I move on to talk about some like concrete evaluation experiments that we did.
And I have a follow-up question to that
one,
which is, I think what's funny about your example is that the question is literally a source. Well, I think it was a source memory or source attribution. It's a source attribution question. So accurate. So the literal answer to the question is more high accuracy if you have a source, better source attribution, right? So.
Oh, you mean because the question was, what does the American Heart Association say?
So it's wrong if it tells you something true about PUFAs, but that the AHA didn't say. Right. And so part of what you're saying is also, okay, if you want answers about PUFAs, right? You want the right answer. We also want the right source. So yeah, you raise a very interesting point. So
there's a reason I chose the example of asking about what the AHA says about PUFAs rather than asking just what's true about PUFAs. And that's because if you do source attribution, the answer is very easily verifiable. Because like the question of, what does the AHA say about X is not like a conceptually complicated question to evaluate. So it's very easy to kind of tell the difference between the kind of reliability of a source where it's like, that it's drawing a snippet from the web page versus it's a language model kind of doing whatever, right? Because when Google is drawing a snippet from a web page, we have a very clear generative model kind of like what needs to be true in the world in order for that output to come out of our screens. Is that like that text almost certainly needs to be on that web page or on like a recent version of that web page. And so our model of how the system works can be really, really effective at improving our confidence in the actual answer to our question. If what I'm interested in is, are PUFAs good for you? It becomes a lot harder because now my generative model of the output of the system has to relate to my model of like, what actually constitutes good evidence about whether PUFAs are good or bad for you. And so because I'm asking a scientific question, my model of how the machine works would have to relate in some way to my understanding of how we should evaluate scientific knowledge.
Yeah, like that's it's a tricky domain, but I guess I guess, we'll see how your experimental paradigm is set up and everything, but I guess my question is sort of, if what we're interested in is how people evaluate what is good evidence, you're sort of constraining the space to saying, okay, this problem is about attribution. Whereas if, let's say in a different example, let's say I want an answer to a question, how many people die from heart attacks? Then you get some answers, some of them are right, some of them are wrong. You could vary how well the source is credited separately from that. Separately from accuracy, whereas in your example, they're kind of bound up. But I see why you did that. It makes sense.
Yeah.
But it was a little different from the question of, if I want a fact, and then how does the source help me believe that fact?
Right, right. So you need to have a model, like in practice, what this would look like is having a model not only of what source is the information coming from, but how trustworthy is that source and how much does it align with reality. So this is also something that like individual users might disagree on, right? With respect to like what sources do you trust? So actually, like one kind of random idea on how you might try to implement a system to be more legible in that way is, suppose a user has a certain epistemic standard, right? Maybe they're like, I don't trust reports out of like these organizations, but I do trust reports out of these. And if they can build that into the system and know that the sources that the system is using come from trusted sources, then they can trust its output more on that basis, right? And so it's about like building a richer model of how the system works so that that the inferences that you can make about the world are grounded in your understanding of the
field. And I think that's also why I'm interested in the difference between these examples, because if I'm specifically demanding a source attribution, as in what does AHA say, maybe some model will be fine with that, but that as a general habit, it's actually not really specific about sources. Because one of the things that happens with memory in general, right? This is like human memory, but also computational models thereof, is that you can actually lose those links to sources when you generalize a little bit too broadly. So yeah. So
in that case, on what basis should you trust the outputs or that memory that's now disconnected from its source?
Well, this is what's funny, like for the human mind, we have a lot of factual knowledge, we've lost the source attribution. I mean, how we trust ourselves and metacognition is a whole topic, but for whatever reason, most of my facts about the world are disconnected from where I learned them from. Yeah. And somehow I operate in the world.
But yeah. I mean, maybe your kind of process for integrating those facts is kind of trustworthy enough that you can defer to it, right? And like in practice, if you get used to using one of these AI systems, like probably you start to get a good sense of like important for not having kind of like higher stakes failures.
Yeah,
right.
totally.
Yeah. So having a good model of the system comes not only from things like tooling that's built in, but also experience with like just being calibrated on like when is the system more or less reliable, when is the system more or less likely to do something that I want. Yeah.
Really good comment. I think this is a great example, and it almost presupposes a certain model, right? Like you could imagine asking, what does the AHA think about PUFAs, because the user wants to figure out how it relates to heart health, right? And if they wanted like the formula, the chemical, meaning of a PUFA, right? They wouldn't ask about the AHA.
Right. Right. And they might also just not really trust language models on these kinds of questions. So they want to make sure that they're getting something from a trusted source. Like they would trust the model maybe much more to summarize existing web pages than to just like come out with like reliable information, for example.
Which, like, if they were like, please summarize the findings and pros cons of PUFAs for health, like it might actually do better.
Mm-hmm. Yeah. Yeah. And in fact, that was when I think I originally, when I was constructing the example, I basically asked our pros and cons, which then you could like kind of go check against sources if you wanted, which is like probably a more useful paradigm than just looking at one source. Yeah. Yes.
So I do want to make sure that we're not kind of like giving your claim, your evaluation approach, that we're not setting up Google to succeed as just like the most transparent model, because it's very dumb, right? It's not generating knowledge, it's just pointing you somewhere.
So
transparent in a way. Also, there are like a couple of ex-Googlers in this room, which I think makes us more critical of them than not. But like, if you take something like Google that just gives you a pointer to the source, not trying to like generalize at all, not trying to like generate knowledge at all, versus like a deep neural net, which is like one of the most opaque things I can imagine. And like, I have no mental model. I figure these things a lot, but I have no mental model for like what is actually going on there. Maybe this is like what we're going to get at next, but just like how do we get the knowledge building capacity of models, but also the transparency that something like Google has, where it just does not, it doesn't explain anything, it just like points you to the source.
Yeah, so that's a great point, is that like Google totally counts as like a system which we can measure kind of alignment with. And I think it does a great job in a lot of ways, because like our model of how Google relates to the world is like pretty clear, right? That it points to web pages that someone has like put online. You have some idea of like what it takes for someone to put information online on a web page. If you have a bad model of that, you're probably going to fare worse when trying to answer questions with Google. But there are also aspects that are opaque, like you write a question and you get like the top 10 results, but do you have a good model of what is omitted? And do you have a good model of like, so there's this notion of Google foo, which is like, how good are you at designing search queries that are likely to surface things that you want? So I think there's still kind of a lot of room for this question of like, how good is your model of Google to help you in collaboration with Google? It sounds like you're like not satisfied with Google. You're saying, no, we want to do better than Google. Google's not good enough. Yeah, how do we build systems that are kind of like more transparent and help us get further? I don't know. I'm gonna present an idea in the next section. But the main point that I want to make is about a way of thinking about what it even means to make progress and how we should measure progress. Because I think the fact that like Google is kind of a formidable baseline here actually speaks a lot to like how far we have to go with respect to making language models really useful.
And maybe like if I understood your point correctly, there's a bit of a trade-off, because that transparency, it's like that sheet of glass rather than the opaque black box. The black box is doing a ton of work for us, obviously. So those may be in tension.
For sure. Yeah. Yeah. Yeah, and I think that like there's this idea that that we've made tons and tons of progress because we can build black box models that get high performance on question answering, whatever else. Maybe if you compare to like assume that the first Google result is correct, you get much higher performance. But then it's like, okay, if you put a human in dialogue with a language model and in dialogue with Google, does that gap start to close? And I think that's a really interesting question. Yeah. Any other questions before I move on? Okay, cool. So, okay, I'm going to talk about our experience trying to put this idea into practice using debate. So that's what we're testing here is not a specific model, but a supervision paradigm, basically a model architecture. So as kind of background, the default in how we use language models is what I might call something like conversational supervision. So say I have some questions, do the benefits of dietary linoleic acid outweigh the costs? Again, PUFAs, but it's fine, right? So if you delegate this question to a language model, you ask it, and then maybe it says no, right? And it says some stuff about, research associating, high omega-6 intake with, good or bad things or whatever. You have a question of like, okay, what do I conclude? The language model says no. How much credence do I give to this result? And the answer to that might be very different depending on my pre-existing beliefs. Maybe I've read a whole bunch of like these online blogs that talk about how bad seed oils are. And like, if it doesn't address my concerns there, I'm going to be like, I don't think this is a good response. Or maybe I kind of really trust the establishment. The American Heart Association is like, they're great, they lower cholesterol. And I'm like, if they don't address that, then I'm not going to be happy with this response. So that the way that I evaluate and interpret the outputs depends a lot on my pre-existing beliefs. And if you optimize a system to give outputs that you will approve of, then you risk not really being aligned with truth. So there's this risk of sycophancy where the ability to distinguish between what's actually true and what seems true given your current beliefs can potentially be exploited by a system. And that maybe undermines our values at the end of the day. So one of the approaches that was proposed to combat this is called AI safety via debate, originally proposed back in 2018. Basically, it's like when you hand a question to a model, it proposes two distinct answers and then it debates itself over what the correct answer is. And the idea of debate is that it should converge to the correct answer as long as it's harder to lie than to refute a lie. Where basically like each model has made a claim and then it tries to refute the other side's claim and then it refutes that refutation and so on and so forth until eventually the debate kind of converges and there's like an unquestionable winner. So as long as lies will eventually get exposed in the end, debate should converge on truth, right? But this is kind of an empirical question of how well this works, when this works, why this might work under what conditions. And insofar as we're interested in debate as a method for helping us kind of find truth, we want to test this empirically. So for our experimental setup, we basically do, we instantiate the setup I mentioned in the last section, where we're looking at this kind of human AI collaboration setting. But we kind of specify it to a particular distribution for the sake of making things practical. So sorry for those of you here in person, it's kind of like halfway blocked by the TV. But so we use a data set called Quality of science fiction stories. They're short stories with like 5,000 to 8,000 words with reading comprehension questions over them. And we are basically asking a judge to answer these reading comprehension questions without reading the story. So the judge does not have access to the ground truth and does not have access to the story, but the debaters do. The debaters can see the story, can read from the story, and they even have a quote tool, so they can draw verbatim quotes from the story that the judge can see and know that these quotes are verbatim. So it's basically a question of like simulating a situation where the judge doesn't have the relevant knowledge required to answer the question. There's some part of the world that they can't see, and they need to interact with a system in order to gain that knowledge. To assess whether the debate works better than the kind of default conversational supervision, we use a baseline we call consultancy, where instead of having two debaters, each of which defends one answer. We just have one debater that defends one of the two answers, and they're assigned to one of those answers at random. So 50-50 arguing for the correct or incorrect answer. So the reason we structured it this way with, well, I mean, so this is a little bit retrospective, but like the way that this fits into the framework that I provided earlier is that by hiding the story from the judge, we basically peg the human baseline to 50%, because, and we get their priors in practice that like they get 50% accuracy on the first round of the debate before they've seen anything. And the AI accuracy is also pegged to 50% because it doesn't actually output which answer is correct. So in consultancy, you know that it's arguing for the correct answer with only 50% probability. In debate, it's arguing for both. So the system itself doesn't output a correct answer in that sense. In order to deviate from 50%, you have to gain useful information through interacting with the machine. Does this setup make sense? I feel like I usually miss one or two details anytime I share this. So
without reading the story,
Yeah.
they're at 50%.
Yeah.
If they read the story and don't debate, what is it?
Our estimate of human accuracy in that case is around like 93%, 92, 93%. Yeah. Yeah, against the gold labels.
I don't have a fully formed thought yet, but I want to make sure that the consultancy baseline is like a fair baseline to compare this to when you're entering like the improvement from debate based to something else. Like I feel like there's probably something in between where we could do a little bit better than just a random answer being argued for.
Yeah, so the challenge is, for example, if you were to use like an AI system trained by RLHF, right, some existing language model, it's going to get the question right most of the time. And so if you put a judge in conversation with a model that's getting the question right most of the time, then the amount of information that they stand to gain by interacting with it is a lot smaller. And so the kind of cost benefit to actually not just deferring is a lot worse. And it will make it a lot harder to tell the difference between the debate and consultancy setting. There's also the fact that we would need to, in the debate setting, provide a prior on the answers. And we don't have like debater trained models that provide such priors. And the one thing that I knew I forgot to mention something, is that we're interested in testing debate as a protocol, which means we want to test it in the setting where we're optimizing as much as we can. So the incentive here for the consultant is convince the judge. The incentive for the debaters is convince the judge. Turns out current AI systems are not super great at debate, and it's kind of hard to get them to debate well. And what we're interested in is how good does the supervision protocol work if you push it to its limits. So we actually did these experiments with humans. So we had human debaters and human judges. So for debaters and judges, we hired 13 NYU students, and most of the co-authors on this work debated and judged. The NYU students were almost all from the competitive debate team. The one who wasn't had 6 years of studying Talmud, so he was also very experienced in argumentation. In fact, he was the best at deception by far, but he was also like one of the worst judges. You know, like people have different skill sets. But yeah, so we collected data from February to August last year. And we collected 500 or so interactions, including, we actually also did a debate with AI debaters, but I'm just going to talk about the human results here, which are the kind of really the main results. And you can browse the data online if you want, at the URL here. So the results, okay, all right, I have it in the text. So our human and AI baseline, as I said, are pegged to 50%. But debate was more accurate than consultancy by 10%. And this was statistically significant. We had pretty small data here. It's like around 100 examples of each, because it was extremely logistically challenging and expensive to kind of collect this data, because you're wrangling a bunch of undergrad debaters and you know, you have to like read a whole story and then craft like a really good argument that you fit into 750 characters like 5 times to finish a single debate. So this was a kind of intense data set to gather. But what we found is at the end of the debate, the judge was 84% accurate in debate and 74% accurate in consultancy. So they were quite a bit better in debate. And debate was also a lot more efficient. So it took 2.7 rounds on average versus consultancy took 4 rounds on average and sometimes went on for a very, very long time. And when we look at the data, the kind of reasons for these differences make sense and are promising. So first of all, if we look at judge errors on debates, they mostly seem easy to overcome in comparison to consultancy, where kind of there were like aspects where maybe the judge was taking risks and ending the debate too early, or the honest debater, like the debater that's arguing for the correct answer, just like missed a really important argument or a piece of evidence that they really should have included. So those are cases in which, with a little bit more judge training or care in judging, and with like stronger debaters, say if you have like a very powerful AI system, we would expect the accuracy of the system to go up. Versus in consultancy, a lot of the errors resulted from the consultant being able to kind of cleverly hide some information from the judge, which was not always easy, because the judge could basically tell them to quote from like specific parts of the story by like word index or whatever, or like ask them to expand quotes that they gave, or other things. Like you could do quite a bit to kind of interrogate the consultant and try to get useful information, but still you did quite a bit worse than in debate. So what does all this mean? Basically, for a certain domain of questions, these reading comprehension questions, and a certain skill level of system, if we optimize for convincing a human judge, attempting to refute our claims helps us seek truth. That's what I think these results kind of point at. That debate is useful as a supervision protocol, whatever the system might be, if it's optimizing for convincingness. But we want to know much more than this, right? We want to know about questions at the edge of human knowledge. We want to know how this will work for increasingly advanced AI systems. We want to know if this trend will kind of continue to hold, and we want to know how strongly. So there's actually been more progress on these fronts. I helped gather a data set called GPQA of like really hard scientific questions that my collaborator, David Ryan, led, which I would encourage anyone looking at this data set. It's like, these are really, really hard questions. It's like the hardest benchmark I've ever seen. I love these questions. And our hope is that with these super hard questions, we can start to test debate at kind of more advanced levels, either with humans or with models, once they're at the point where they can do this kind of debate. Because that's kind of a test bed for this question of, okay, can we start to reliably advance human knowledge using these systems?
That was
yes.
actually my question, is how do language models do debate right now? And is there, I bet there's an interesting empirical research program of how they debate.
Yeah, so the thing about language models is they're like highly instructable too. So often it's a matter of like, in a specific domain, there might be certain kinds of strategies that you need to use to debate well. And it takes a lot of prompt engineering to make that happen. So in Akbar Khan's project, so I didn't co-author this work, but I'm very excited about it, where they basically took frontier language models and then created a whole bunch of different debaters out of them by just like hardcore optimizing the prompts and then doing best of n kind of things, where essentially you would produce n arguments and then judge them against like m other arguments that you produced and identify the best ones on the basis of judging, and then use those in the debates. And so you could get stronger debaters by doing this. But it takes a whole lot of prompt engineering right now to get like a reasonable looking debater. We have another debate project, like a human debate project going on over code, where the task is you have like a non-coder judge, and they're looking at like a Python program. And the question is, what is this program going to output? And then we have models trying to argue about like, here's what the program will output in a way that convinces us non-coder. So we're trying to kind of like bridge these very large expertise gaps, where it's like, what if a model invented entirely new science? Could you still actually like determine whether it was coming to the correct conclusions or whether it was arguing for the right conclusions? And the prompt engineering for this coding project is like a whole separate thing. We can't just reuse the prompts for debates on reading comprehension questions.
That's the thing, is that feels really domain specific. And what I want to know is, what is the theory of what makes a good debate point? Like the method of debate and nudging the model, not being like specific about the prompts, but nudging the model towards that process.
Yeah. So that's a great question. So in the limit, right, the idea of debate is just optimized for what's most convincing to the judge. But what is convincing to the judge? It actually depends. Well, not only that, but like it's actually up to us what the judge uses to judge, right? Like the judge could just choose to put burdens on the debaters, and then if they don't meet those burdens, be like, aha, like no, I'm not going to vote for you, right? Like the judge can actually be any kind of policy for evaluating arguments. And the question is, okay, if we choose some judging policy and then we optimize against it for convincingness, like what policies emerge? And that's like a really interesting question. Also, like, are those policies ultimately truthful and truth-seeking? Depends on what criteria your judge uses. Like, it's like, if your judge has certain kinds of like blind spots or very strong priors or other kind of exploits, then you wouldn't expect this to work.
Otherwise,
right?
Human, right? Like we've all got these cognitive biases.
Right.
We're never neutral, purely truth-seeking. So,
but are we capable of designing a judging policy that can be neutral and truth-seeking, right? So then it raises a question of like, is the only way of doing this using humans as judges, or like what we've done is basically reduce the problem of like generating the truth to the problem of evaluating arguments against each other, which is like maybe it's still a hard kind of alignment problem, but more tractable than the former. And so essentially what this points to is like a research program of empirical epistemology, which is to say, okay, if I like choose some judging policy and optimize against it, what are the optimal strategies and do they converge on truth, and what are the cases in which they do and don't? And that feeds back into our decision of like, well, how should we be evaluating arguments in the first place? And there are a lot of kind of technical things that you have to deal with here, which is like, for example, like how do you make sure you explore the space of possible arguments? What if your exploration is biased by the pre-training that you give these language models? Yeah, how do you make sure that your judging policy isn't overfitting to the kinds of things that you're testing? So actually, like, yeah, my thinking on this, right, is we eventually want to generalize to questions that go beyond existing data. There's no ground truth to check against, but we want it to still be right. Within our capabilities, we have the convenience of the sandwiching paradigm, where we're like, okay, we can use our theory of AI debaters as powerful persuaders to then identify the truth as that which is robust to refutation, and then we can test this against ground truth. We can show that it works. But we want to extrapolate beyond data that we have. Any extrapolations that we make are going to be based on our theories of those systems. Theories like, oh, it's a powerful persuader, and I'm going to assume, for example, that if there's a claim that's made in a debate that is not refuted, then that's a signal that it's likely true because there does not exist a refutation that the system would find, right? If we want to extrapolate beyond current data, using our theories of how the system behaves, then I think our extrapolations will be truthful in so much as our theory of how the system works and connects to reality and our theory of truth actually coincide with each other. So the question is, how do you implement a truth-seeking process in a system? And the sandwiching paradigm is a way of is it like a necessary but not sufficient test for verifying that the theory of truth you've encoded in your system agrees with kind of socially agreed upon truths. And so this question that I had earlier of like, okay, success in this game depends on our ability to model the AI system and how it relates to the world, isn't just a question of can we understand how our AI systems work? It's also a question of how should we build our AI systems, right? On the basis of what theories should we build them? So I think that our task is not just to understand AI systems, but to understand and implement theories of our values. And like that sounds very hard, but hopefully I've convinced you a little bit of how we can start to measure and make progress on this. So that's the content of my talk, and I will take any further questions.
I have a question, Julian, almost there also. I'm curious about task-based benchmarks for, it seems like this would be, yielding towards some kinds of evaluations. I don't have an answer what this would be compatible with or not compatible with, but curious to hear your thoughts. Like something like debate is conducive to certain aspects of AI capability, while like writing a poem is about others. So I'm curious about what is the category of tasks that you think this is well suited towards.
Yeah. Great question. So what does debate help us with? The places where I would expect debate to help us are cases where we're limited in our ability to evaluate the quality of inputs based on attentional constraints, time constraints, or knowledge constraints, where you can expect that, like, if a certain piece of evidence or a certain argument or a certain maybe like logical fallacy or something like that in an argument is raised to your attention, then you will be able to correctly kind of incorporate it into your assessment, but it might be very hard to find that on your own, where you can rely on the optimization power of the AI to like search for the most relevant arguments and then present them to you. And so, for example, like when we have these hidden information settings where you, in theory, would need to comb over a whole lot of information to like figure out what the best answer is, I would expect debate to help a lot. But suppose you're in a case where like you don't know exactly what question you should be asking, right? Like maybe you have some like general goal that you're trying to achieve, but you don't know exactly how to put it into words, or you ask a question that kind of has a false presupposition in it and you don't know it. The debate paradigm doesn't really have a clear way of handling that. Yeah, I think it's the kind of thing where like if you expect further reflection and processing lots of information in like a relatively deterministic and well-defined way to lead you to converge to a better conclusion, then you would expect debate to help. But if it's not obvious that it would help, then yeah, I think it might not do as well.
Yeah, I kind of a related question, just like how do we escape a place where people can be debating over a completely false premise, or like we can debate in this room about like how like what the size of the flat earth is and like how many miles wide is it and like what happens to the water at the end, and so that's like we're just like completely under off that. And so I feel like we need some grounding in.
Well, we have to be able to challenge premises,
Yeah.
premises and arguments.
Right.
Yeah.
To break that.
Yeah.
Right. So if you ask a question with a false premise, then you have a notion of like, what is a correct answer to that question? And I think this kind of is easier to view if we kind of back off from the notion of correctness back to the notion of utility. That we're not only talking about figuring out things that are true, but also things that are useful. And so if we ask a question that's grounded in a false assumption, I think ideally you would want the system to be able to kind of like raise your attention to like where your assumption might be false, and help you reflect on that question and seek out the relevant knowledge to like identify the false presupposition. It's very unclear to me what the right objective for that is, right? Because you can imagine having debates that kind of converge on the basis of these false premises, and like maybe if you don't have the option of revising the answer or revising the question, it would be difficult to incentivize something better happening. But also like what actually determines what are the right questions to ask, right? Like ultimately, for a question to be meaningful, I mean, maybe this makes me kind of a positivist or a pragmatist or something, which I'm all of those things. But like for a question to be meaningful, it has to have implications about how you'll act, right? So I think like maybe one kind of thread to pull on there is if there's a question that doesn't make sense, what you want to ask is like, okay, what is the action that you're considering taking on the basis of the answer to that question? Because that actually is what determines the meaning of the question. And now your task is to evaluate the utility of that action, and what action would kind of like be highest utility to you. Now, there's also the question of like, do you know the utility of your actions, right? Like, how much do you know about your preferences? And do you want such a system to optimize towards your immediate preferences or maybe your idealized preferences? And if it's an idealized version of your preferences, how do you go about that idealization process? So like, we're kind of rewinding a whole bunch of philosophy here, which is, I think, ultimately what needs to be done. Yeah, but debate does not provide immediate answers to those things in my mind. Yes.
That's need to solve all epistemology.
Well, yeah, but hey, we can make empirical progress, right? Actually. Yeah.
Also for your question, I mean, the relevant utilities, do I fall off the earth? How far can I walk before I fall off the edge? That's the it's very clear.
It's also a self-correcting system. You gotta accept it.
Yeah.
Okay.
Kind of related, I realize you're using different existing frontier models. Have you, I don't know what the state of the art is, but in terms of tuning these models, or are they checked specifically for debate type paradigms, or like this is an effective style, or like this is how to challenge the prompt, or any of that kind of work?
Yeah. So when we did our human debates, we actually had a bunch of feedback sessions discussing strategy and trying to kind of like identify how to do best at these debates. I don't think we totally converged. One thing that seems to be true is like the specific strategies sometimes depend on like the setting that you're in. So like they were maybe specific to like having good priors over what happens in these stories. There were some like stylistic features that came up where like people were like, oh, if the debater is like quoting a whole bunch of disparate short words, then that's very suspicious. But then like once you know that, you can kind of adjust for it and it no longer becomes a meaningful signal. And so the process of optimizing is kind of like you let the debaters try to exploit the judge, and then the judge kind of then can adjust on the basis of that. And so I expect it to be an iterative process. We are actually working on training models to debates. That's another project we have going using open source models. And we recently had our like first minor success where we have a graph with like a positive slope that basically says as your debater gets stronger, then if you do self-play, like if you just debate yourself with like an LLM judge as well, then it's more truthful. So that's a trend that we want to see, is as your debaters get stronger, the outcome gets more truthful. But like the stuff that the models are learning at this point, I mean, so we're using like Mixtral, and it's learning to like be better at verbatim quoting and stuff. Like there's still a lot of kind of, I think, stuff left on the table. There's a lot that we need to do with regard to like exploration. The models also just like aren't super good at debate, like especially because the models we're using were RLHF'd. It's kind of hard for them to like disagree and to clash with each other. Another really interesting thing that happens is they seem to have no real concept of the relationship between claims and evidence, where like they will like make a claim about something that happened in the story and then provide a quote to like back up that claim, but the quote is just some random line of dialogue that like happened in the scene that they're describing. And they're like, and so I've shown that that thing happens, but it's like they just claimed that it happened. They didn't actually show it.
They're just a freshman level of college. I'll get there.
So, you know, there are varying perspectives you can have on that, but it like, yeah, reading these debates, the like really frustrating thing about like trying to find the right answer is like there's like no concept of like the relative reliability of claims and evidence. Like the models don't seem to know that they are untrustworthy and kind of like act like it,
Yeah.
if that makes sense.
They picked up on the style of debate and not the actual
Yeah.
underlying structure.
Yeah.
And that's exactly what I was sort of asking about, is like the very process of debate, like having, being able to appeal to something like the relevance of a fact towards an argument.
Yeah.
Need that.
Yeah, I think there's a lot of work to do in like getting that to work and work well. The kind of like MO here is to figure out how to evaluate it and then trust that like scaling and big labs and lots of people engineering will kind of figure out a lot of these details. And as long as that we have like a really strong form of evaluation, then like we can know what
Your relevant claims and evidence as the primitives that you're generating or working on, right? Instead of next token, or instead of
I'm not sure if what you mean is kind of like internal reasoning mechanisms driving the model, which I think that's just like a general problem with neural nets, that like it's just very hard to just like here it is. Here's like we just told it how to reason and now it's doing it. That's just very, very hard. But I think that there's a lot that could potentially be done in terms of like the interaction paradigm, where instead of just outputting a string of text with like some quote tags in it or something, you output structured arguments, for example, on a flow. So in competitive debate, okay, this was practiced when I did competitive debate, was you would flow the arguments on each side where you'd separate the points and then you would respond to them in kind and draw all these arrows and say like, here's what I'm responding to here and here's what I'm responding to here. And it made it a lot easier to kind of like evaluate an argument. And I suspect adding some kind of scaffolding to the debate like that could kind of guide the debaters to do something that's closer to what we think of as truth seeking. And like make it just a lot easier for the judge to evaluate the debate. And I think that we could potentially mine argumentative theory for this kind of stuff. Yeah, but ultimately I would want to basically, on top of that scaffolding, rely on, yeah.
Yeah, I guess there's multiple goals, but one goal could be to like build a system that does this really well and in an explainable, interpretable way, maybe with some chain of thought, right, or this scaffolding, or have a generic human be a good judge with a generic frontier LLM the way that they are now, right?
Yeah, so, and what I think is great is that we can actually evaluate these approaches against each other with like the evaluation paradigm that I presented here, where like you should be able to, if you're producing a more interpretable system, like your measure of is it actually more interpretable and explainable is, does it allow you to make better inferences about the world on the basis of its outputs? And we should be able to see that beyond just the kind of black box accuracy numbers that you normally would be used to getting out of these systems.